Today we will study the mixed integer programming problem. The given LPP is maximize z equals to x1 plus x2 subject to the constraints, and x1 is an integer. Now introducing the two slack variable s1 and s2 which are greater than or equals to 0. The standard form of the above LPP becomes maximize z equals to x1 plus x2 since we have taken two slack variables. So it is added for the objective function. So it is 0 into s1 plus 0 into s2 subject to the constant 3x1 plus 2x2 plus s1 equals to 5, and the second slack is added for the second inequality so that it becomes equals to 2. Now corresponding the condition x1 x2 s1 s2 they are greater than or equals to 0. Assuming x1 x2 equals to 0, we will get the initial basic feasible solution as s1 equals to 5 and s2 equals to 2. Now ignoring the integer condition and solve the problem using the simplex method. The initial table is CB, BXB, X1, X2, S1, S2, and here since the initial basic feasible solution, the basis you got it as S1 and S2, write the basis as S1, S2, and the coefficient of S1, S2 present in your objective function, that is 0, 0, that's why right here it is 0, 0, and the value of S1 and S2 they are 5 and 2. Okay, the first row related to the first equation of the constraint, and the second row related to the second equation of the constraint. 0 1 0 1. Now go for the finding the value of Zj. Now Zj is nothing but summation of Cb into Xb, Cb into Xb. Okay, 0 into 5 plus 0 into 2. Sum of these two is written here. So 0 into 5 plus 0 into 2 is 0. So similarly remaining 0 into 3 plus 0 into 0, that is 0. 0 into 2 plus 0 into 1, it is 0. Similarly you have to write all the values. Now go for Zj minus Cj. Zj is here, Cj at the top. So 0 minus 0, here it is 0, 0 minus 0 minus 1 is minus 1, 0 minus 1 is minus 1, and 0 minus 0 it is 0. Like this you have to write Zj minus Cj. After writing the value of Zj minus Cj, you have to select the least among the value of Zj minus Cj. So least value is minus 1. That column represented entering variable. So entering variable is nothing but x1. So here in this side you have to do xb divided by x1. xb divided by x1 in the sense xb divided by x1. 5 by 3 and 2 by 0. So 5 by 3 it is keep it as it is, and 2 by 0 is not defined, it is infinity. So ignore this one. So this row and this column where they are coinciding, that becomes the key element. Okay, 3 is the key element. Now the next step is you have to make this key element as 1. So for that write the transformations. So before that write down the row as R1 and R2 for this, and for this transformation you are writing that R3 changes to R1 by R3. R3 is nothing but a new row. Okay, now R1 is divided by 3, and whatever the new transformation comes, that you have to fill in R3. And here the key element is x1, key element is nothing but x1. So here the living variable becomes s1 and entering variable becomes x1. So you have to replace the value of s1 by x1, and the coefficient of x1 present in our objective function is replaced here. Okay, basic cost value is replaced by 1. So the same thing is here, x1, s1 is replaced by x1 and its cost is 1, that's why you have written it as 1. And the remaining all values you have written the transformation R3, it changes to R1 by 3. So you have to write 5 by 3, 1, 2 by 3, 1 by 3, 0. Below that key element, already the element is 0. If it is not 0, then again you have to take the transformation for this and make the element to be 0. Okay, this is same procedure as like our simplex method, no changes. Okay. Okay, Zj minus Cj, once again after filling the value, now you go for Zj and Zj minus Cj. Calculate the value of Zj minus Cj. So after that again identify the least value. Here minus 1 by 3 is the least value. Select that column and write xb divided by x2, because this is present in your x2 column. X2 column, that's why it is xb divided by x2. Here xb is 5 by 3 and x2 is 2 by 3. 5 by 3 by 2 by 3 you will get it as 2.5, and here 2 by 1 you will get it as 2. So the least among these is nothing but 2. The row, this row and this column where they are coinciding, that becomes the key element. Okay, now here the key element is 1, no need to go for the transformation. Now the changes will take place in the basis. S2 becomes the living variable and x2 x2 becomes the entering variable here, and the coefficient of x2 is replaced by in place of 1. In place of 0 it is replaced by 1. Okay, because the x2 coefficient in your objective function is 1, so that it is replaced by 1 now. So that is written for the next table. x1, x2 coefficient in our objective function is 1, and write down the key element row as it is. Okay, so first you have to write the key element row as it is. Now you have to change the above this key element, whether the element is 0 or not. Here it is 2 by 3. Now you have to make this 2 by 3 as 0. For that you need to write the transformations. We are writing the transformation as R5 changes to R3 minus 2 by 3 times of R4. Okay, so we are multiplying this row by 2 by 3 and we are subtracting for this, so automatically this becomes 0. Okay, now you have written the source row as it is. By this transformation you will get the elements like this: 1 by 3, 1, 0, 1 by 3 minus 2 by 3. Again calculate the value of Zj. Zj is nothing but product of Cb into Xb and its summation of Cb into Xb, 1 into 1 by 3 plus 1 by 3 into 1 plus 2 into 0. So it becomes here it is. Okay, now you calculate the value of Zj. Zj is nothing but sum of the summation of Cb into Xb, 1 into 1 by 3 plus 1 into 2. Similarly 1 into 1 plus 1 into 0. So 1 into 0 plus 1 into 1. Like this you have to write the value of Zj. Once the value of Zj is completed, now go for Zj minus Cj. First row element leave it blank. 1 minus 1. At the top you are having 1. So 1 minus 1 will be 0. Okay. And similarly 1 minus 1 it is also 0. 1 by 3 minus 0 it is 1 by 3. 1 by 3 minus 0 it is 1 by 3. Since all the values are greater than or equals to 0, the value of Zj minus Cj is greater than or equals to 0. We have reached the optimality. Now we have to go for the for finding the Gromorian constant. So for that what we are doing is we have to check whether all the values are integers or not. Whatever the last table you got, the value of x1 is not an integer. So x1 is came out as 1 by 3. So this first row becomes the source row. So pick out this source row separately. When you write that source row, it becomes 1 by 3 equals to x1. That row is written again in the form of an equation. 1 by 3 equals to x1 plus 0 into x2 plus 1 by 3 s1 minus 2 by 3 into s2. So by the condition of Gromorian constraint, in order to in case of mixed integer, what we have to do is we have to consider this element as fk. So when you consider this value as fk, in the sense your summation will be represented in the general form, that is summation of fki into xj is greater than or equals to fk form. Okay. Now the rule is we have to take the coefficient of a negative value along with fk divided by fk minus 1. Okay. Here the coefficient of negative is minus 2 by 3. For this you have to take the fraction as fk divided by fk minus 1. So the element becomes, only you have to take the fraction value, not x1 and x2 values. So go for only decision slack variable coefficient value. So it becomes 1 by 3 s1 minus 2 by 3, keep it as it is. For this minus 2 by 3, whatever the fk value is there, that value is written as fk divided by fk minus 1. Fk divided by fk minus 1. This value is greater than or equals to your fk value. Fk is nothing but 1 by 3. Okay, simplify this, you will get 1 by 3 s1 plus 1 by 3 s2 greater than or equals to 1 by 3. Now multiply by negative sign on both sides, you will get minus 1 by 3 s1 minus 1 by 3 s2 less than or equals to minus 1 by 3. Now you have to add the Gromorian constant for this. So it becomes minus 1 by 3 s1 minus 1 by 3 s2 plus g1, this is equals to minus 1 by 3. Now you got the new constraint for this. You have to add this constraint equation for the last table of your simplex table. That is the last table containing only x1, x2. For this table we are adding the Gromorian constant now. Okay, write down the basic table as it is. So x1, x2 also as it is. Next the new member is nothing but g1. The coefficient of g1 in your objective function will be 0. Okay, this is 0. when you write it is coefficient is 0, and the g1 value, when you assume s1 s2 equals to 0, you will get the value of g1 is minus 1 by 3. So write that as 1 minus 1 by 3. The coefficient of x1 which is present in a Gamorrean constant, x1 is not there, so that's why it is 0. x2 is also not there, so it is 0. And s1 coefficient is minus 1 by 3, s2 is minus 1 by 3, g1 is nothing but 1. Now again find out the value of zj, that is summation of cb into xb, 1 into 1 by 3 plus 1 into 2, plus next one is nothing but 1 into 1 plus 1 into 0 plus 0 into 0. Like this you have to write the value of zj. Once again calculate the value of zj minus cj. Okay, again from this value, since all the value of zj minus cj already it is reached to optimality, now we have to check whether the integer values they are positive or not. Here you can see the Gamorrean constant value is minus 1 by 3. Consider this as aik value. g1 equals to minus 1 by 3. This position is considered as aik value. The formula is the maximized zj minus cj is divided by aik value. So maximize zj minus cj in the sense here the maximum value 1 by 3, 1 by 3. These values are divided by your aik value. Whatever the remaining value is there, among that we have to pick out the maximum value. So like this, zj minus cj value is 1 by 3 and 1 by 3. aik value is minus 1 by 3, minus 1 by 3. So we will get the maximum value as minus 1. So maximum value is occurring for the same values, two positions, x1 as well as s2. So two values they are obtaining the same value. So arbitrarily you can go for any one value and consider that value as a living variable. Okay, so drop s1 arbitrarily as the entering variable. So drop g1 and introduce s1. So g1 becomes the living variable and s1 becomes the entering variable for the next table. Okay, in the sense whatever the last table you are having, in this table s1 becomes the entering variable, this becomes the entering variable, and this becomes the living variable. Okay, in place of g1 s1 will come now, and the coefficient of s1 is 0. You have to write here 0. Already it is 0, no need to change it. Okay, g1 is replaced by s1. That table is to be added for the next one. Okay, first two rows as it is, s1 s2 basis as it is we are writing, only we are changing s1 g1 by s1. Okay, after that we are writing the table like this. s1 is replaced and here it is at a time you have to make the key element is also equals to 1. So whenever the entering value and living value is identified, this becomes the key element. Okay, so when minus 1 by 3 becomes the key element means you have to take the transformation. What transformation you have to do? You have to make this key element as 1. For that you have to multiply this row by minus 3. Okay, when you multiply minus 3 here, so automatically it becomes 1 0 0 1, and here it is 1 and here it is minus 3. Okay, so this row is multiplied by minus 3. Similarly above the key element you have to make the element to be 0. So already this element is 0, no need to change the x2 row, keep x2 row as it is for the next table, and this last above first row is changed as sum of these two. The new row is converted as the old row plus this. If you add these two rows, automatically this element becomes 0. By these transformations we will get the last table like this, that is 0 2 1 1 0 0 0 1 0 0 0 1 and minus 1 1 1 1 0 minus 3. So the corresponding to this, okay, once again you calculate zj value, summation of cb into xb, 0 into 1 plus 2 into 1 plus 0 into 1, so it is 2. Similarly 1 into 1 plus 0 into 1 plus 0 into 0, that is 1. Similarly remaining values, zj minus cj is first element, leave it blank, the 1 minus 1 it is 0. Here the value of cj's they are 1 1 0 0, so 1 minus 1 it is 0, 1 minus 1 it is 0, and here 0 minus 0 is 0, 0 minus 0 is 0. Okay, and the Gamorrean constant 1 minus 0 it is again 1. So all the value of zj minus cj are positive, and the second condition is in the basis value, the value of the basis they are all integers. So you can stop your process and you can write the conclusions. the solution is, the current solution is a feasible solution, and we have reached the optimality, and the solution can be written as x1 equals to 0, x2 equals to 2, and maximize z equals to 2. Thank you.